Carlson here. Let's talk about friction. If I were to take a block, let's say, and let's just say that this block is 5 kilograms, okay, and I were to, let's say, pull on a string or something in this direction with some amount of force applied here, we already know, and we've talked about this many times, that there's going to be a force that opposes that motion, and we already know that that is the force of friction. That is between the surface of the block and the ground or the floor, whatever this is on. As these rub against each other, the ground is going to push back on the block as the block gets dragged this way. Now, we've already talked about different situations with friction. For example, we know that for this block to move at a constant velocity this way, we would have to pull on it this way, or the force applied on it to the right would have to be equal to the force of friction that's pushing or pulling it to the left. Now, we've talked about friction that way. Now we want to talk about how do we actually calculate, how can we calculate the amount of friction that an object experiences? Well, let's think about what are the things that would change the amount of friction that this block experiences. Basically, what could I do to this situation here, or this scenario, to increase or decrease the amount of friction that this block experiences? And one of the things you might think, and you'd be correct, is, well, if I add some weight, let's say, or if I push down on this block, let's say I add another block, which is maybe another 5 kilograms. If I were to add more weight to the top of this, that's definitely going to increase the amount of friction that is between this block and the floor. Because if I add more mass to this, what I'm doing is I'm putting more force downwards, or in other words, the ground is going to have to push up with more force. In other words, these two surfaces, the ground and the block, they're going to be pushed tighter together, right? Which is going to increase the amount of friction. In other words, it's going to be harder for me to pull because these two surfaces that are in contact are now pushed against each other with more force. And so that would increase the amount of friction, right? So adding more weight would increase the amount of force between the two surfaces, which would increase the friction. So that's one thing that friction depends on. How much force between these two surfaces, basically. And the more force that I have, the more friction that there's going to be opposing the motion. Another thing that you might think of is, like, what kind of surface do I have? Are these blocks on something like ice? Because as we all know, if we're on something slippery like that or really smooth, it's going to be easier for me to slide these blocks. Even if I have a bunch of weight, if it's on something like ice, well, then I'm going to reduce the amount of friction. Friction is going to go down because I'm on something smoother. But if I was trying to drag this across something like a carpet, well, that's going to make it way harder. The friction is going to increase in that case because of the surface that these blocks are in contact with. So that's the two main things that friction depends on. It depends on the amount of force that's pushing down on the ground, basically, or the amount of force between these two surfaces. And then also it depends on what's the kind of surfaces that I have. If the surfaces that I have are kind of smooth, then the friction may decrease. If the surfaces that I have are pretty rough, then the force of friction is going to increase. It's going to be harder. And so those are really the two things that friction depends on. And we get an equation for that, for friction. So the force of friction acting on something, force of friction is going to be equal to, we have this symbol here, which is called mu. M-U, mu is what that's called. And then times the normal force. Okay? So these two things are really these two things that we talked about. So mu, what that is called, let's make a note down here, mu, that's called the coefficient of friction. Coefficient of friction. And basically, it's just a number. It's typically like a decimal that's less than 1 typically. And it's a unitless number, but it's essentially just a number that shows us what is the surface that we have, or the surfaces that we're dealing with. So something with a high coefficient of friction, so a higher mu, means that you are dealing with a rough surface. So surfaces that are going to have a lot more forces between them. If you have something that is a lower coefficient of friction, or a lower mu, then it's going to be something that is typically smooth or smoother. So something like ice, that's probably going to have a coefficient of friction that's really low, probably something like 0.1 or something really low, whereas carpet is probably going to have a coefficient of friction that's like 0.8 or something like that, really high. And so we can see in this equation that the higher I make that number, so something like 0.8 or something, that's going to increase the amount of friction. The lower I make this number, the lower I make that force of friction. So that's what mu is referring to. It's called the coefficient of friction, and it depends on different materials. And all materials have coefficient of frictions that we can measure. For most problems that we do, you'll either have to solve for that, or the problem will give you the coefficient of friction, okay? And then for the normal force, that's because, like what we said here, the more force that we have pushing down on the ground, the more the ground is going to have to push up, right? That is what the normal force is. It's the force that the ground has to push up on these objects. And so the more that the ground has to push up, the more normal force that we have, the more force of friction, right? Because the more normal force is because the more force that's pushing down on it, right? Because we know that for these blocks right here, for them to not be accelerating up or down, the normal force is equal to the force of gravity. And so there's our equation for the force of friction. It's just simply what's the coefficient of friction between those surfaces, and then what is the normal force, or in other words, really, what's the mass that you're dealing with here. And just multiplying those two things, that gives you the force of friction that you have between those surfaces, right? One last thing is that we can think about friction in two different cases. We can have what is referred to as static friction, or kinetic friction. And the best way to think about this, so static meaning not moving, right? Not moving. And then kinetic, which is the word for motion. So for static friction, this is when things are not moving, not sliding past each other. And then you've got kinetic friction where they are in motion at that point. So for static friction, that would be like if I have these blocks here and I'm pulling on them with a rope, okay? Static friction is the thing that opposes that motion where they're not even moving. It's basically the thing that keeps that block there. So you can think about as you start to pull and these blocks are not moving, you're applying a force, you're pulling this way, but the blocks don't move. And the reason they don't move is because the force that you're pulling this way with has not yet overcome the static friction that's holding the block and the floor together, basically. You would have to pull with enough force to at least match that static friction. And then once you can match that static friction, you kind of breaks this loose from the floor, and then it starts to move. And then you would notice, and I'm sure you've experienced this before, kind of like if you've pulled a sled or maybe you've tried to slide a box across the floor, once you kind of break it loose, it actually becomes a little bit easier to keep it moving than it was to break it loose. And so when you break it loose, you're overcoming the static friction. Once it begins to slide, now you're working against kinetic friction. And kinetic friction is always a little bit less than that static friction. So static friction is always a little bit more, just a little bit higher than the kinetic friction. It's always going to be a little easier to keep it moving than it is to initially break it away from those static frictional forces. So sometimes you may see for the force of static friction, it may be labeled instead of just F, little f like this. You could see it a variety of different ways, but one way it would be is just like with an S next to it maybe, or maybe you may even see it with just F S like this for static friction, or even SF like this, a bunch of different ways. Just know that that's what they mean. Same thing for kinetic friction. It'll be force of friction, kinetic, or KS, or just FK for kinetic friction. But kinetic friction's for motion, static friction for when it's not moving, and kinetic friction is always going to be just a little bit less than that static friction.